Hello everyone and welcome back to the GCSE Maths Series. Today we're going to be taking a look at area of a sector and arc length. So let's get straight into it. So a sector is a slice of a full circle and it is made up of two radii, which is the plural for radiuses, and a curved edge known as the arc length. And this is my drawing of a sector. Imagine the whole circle, and you take a slice out of it with the angle theta degrees, and this is an arc length. This is the arc length made up of two radii and a central angle theta. And in the example I've provided here, you can see that the radius is equal to 12. Radius is equal to 12. And the central angle is 60 degrees as shown there. And imagine this to be a full circle, but a slice taken out of it as if it was a pizza slice. Okay, now looking at how to work out the arc length. As I showed you in the previous video, the arc length is the curved edge of the sector. So, the formula is described as pi over 360 times by 2 pi r. Now, you might notice that 2 pi r is the circumference of the circle. That is the formula we're given for circumference of the circle. Now, if we're to think about it, look at the angle. The first part of our formula says theta over 360. So if the whole circle is made up of 360 degrees, theta is the central angle here. So we plug in our central angle times by the circumference, which is a representation of the arc length. Okay, so now looking at the first question we have a circle has radius of 7 centimeters. Find the length of an arc that makes a 90 degrees angle at the center of the slice or the sector. So in this case, we are told to work out the arc length when the central angle is 90 degrees. Well, actually, a better representation of this would probably be something which looked like this, but this is going to be 90 degrees. And the radius is 7 centimeters. Now, using our formula, our central angle theta is 90 over our 360 times by 2 times by pi times by our 7. Now, this is going to be equal to 7 pi, I believe, yeah. It's going to be, 7 over 2 pi, and that is the form that this question wants it in. Now, moving on to the second question. Find the arc length of a sector with a radius equal to 10 centimeters and a central angle 60 degrees. Once again, plugging into our formula, we have 60 over our 360 times by our 2 times by our pi times by our radius of 10. This is going to be 10 over 3 pi. And notice how the question wants us to give it to 2 decimal places. So in this case, we pressed our SD button, giving us 10.47 to 2 decimal places. So 10.47 to dp. Now, looking at the last question, we see that a sector of a circle has central angle of 45 degrees and an arc length of 5.5 centimeters. Calculate the radius of the circle, giving your answer to 1 decimal place. So from this, we know that the question is to do with arc length, right? And we know our formula for arc length is theta over 360 times by 2 pi r, right? And from this formula, we have our central angle and our radius, and we know that in this case, our answer is going to be equal to 5.5 because that gives us our that's what they tell us in the question series. So filling in the information that we do know already, we can say that 45 over 360 times by 2 times by pi times by our radius, which we want to find out, is equal to 5.5. Now we can rearrange our formula to make r the subject and then therefore solve for r. So this is going to be, 45 over 360 is equal to 1/8. So r is equal to 5.5 divided by 1/8 times by 2 times by pi. Then plug it into our calculator, we get 1/8 times by 2 times by pi, all are under 5.5, which means the radius to 1 decimal place is 7.0. If you're unsure about how I rearranged my formula here, please check out my video of changing the subject to the formula where any difficulties should be ironed out. Okay, moving on to area of a sector. This is the area, the total area within our slice. So the formula, which I've forgotten to write here, is theta over 360 times by pi r squared. Now, when we're thinking about area of a sector, and we know the sector comes from a circle, hence we have our pi r squared. Remember in our previous formula where we had 2 pi r, which was the formula for the circumference of the circle? Now we're dealing with area of a sector, we have pi r squared, and that's how we're going to remember our formulas. So we now have theta over 360 times by pi r squared. The circle has radius 6 centimeters, and find the area of a 90 degrees sector. So I know it's not to scale, but we can just use our diagram like this, and we need to find the area of our sector. So 90 over 360 times by pi times by 6 squared is going to give 9 pi. And leaving our answer in terms of pi, that is obviously going to be our final answer. Okay, now looking at question number 2, we have that we need to find the area of a sector with a radius equal to 10 centimeters and angle equal to 60 degrees, giving your answer to 2 decimal places. So 60 over 360 from our formula times by pi times by 10 squared is going to give us 60 over 360 times by pi times by 10 squared. It's equal to 50 over 3 pi, but this question wants it to 2 decimal places. So our answer is going to be 52.36. And if you don't know which button to use, it is the button if you're using a class whiz, which is sort of it's above the numbers, but in the bottom right section. So it's going to be the one that looks like this. Press this button and you'll be able to see the decimal places. Okay, a sector has a central angle of 45 degrees and an area equal to 12.5 centimeters squared. Work out the radius of the full circle. Now don't be tricked by the radius of the full circle. Any radius of the sector is going to be the radius of the full circle because the sector is built up from the middle to the end point. So this line here is always going to be the radius. To work this out, we have an expression from an expression of an area through the formula where it says theta degrees over 360 times by pi r squared is equal to the area of the sector. And we know that for some value of r and some value of theta, at some point our answer is going to equal 25 centimeters squared. So filling in the information that we know, we have 45 over 360 times by pi times by our r squared is what we're trying to find. So we have this. Now, rearranging our formula to make r the subject of the formula, we have r equals the square root of 12.5 divided by 45 over 360 times by pi. And once again, if you have any difficulties rearranging equations, I strongly advise you to check out my video on changing the subject of the formula, where I thoroughly go through every single step and every single bit of thought process you need to rearrange any equation at this level. So plugging this in, we get the radius is equal to 5.6 centimeters to 1 dp, as we need here. Okay, that's going to conclude today's revision video on area of a sector and arc length. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video in the series. Peace.